Okay. So, as Justin said, my name is Ben Parker. I'm a system engineer with Palo Alto Networks here in Northeast Ohio. And today I wanted to talk about securing AWS. Since I threw a couple ideas out for Justin when, I think it was 2 months ago, he said, hey, we need some people to talk about stuff. And I said, here's a list of ideas. What do you want to pick? And he's like, AWS. I was like, okay. So, as we start talking about AWS and talk about moving to the cloud, I kind of want to get an idea of where you guys as an audience are to try and better look at what we're doing. So, how many of you are using AWS or working on moving toward AWS? A couple. How about other cloud systems, Azure? Anyone doing Azure? A couple people in Azure. And then there's probably other people doing SaaS stuff. Google, yes, a couple. All right, so that helps. I'll try and, as we're going through here, since there was several Azure people, where stuff is different, I'll try and point out where it's different as well, because there are some differences. And from the other thing, when I try and address stuff, how many people are like on the coding system development side? How many people are like network people? Network people, they do the kind of designing of infrastructures. A couple, all right. And then straight security people, you guys just look at the alerts. You guys design the security. Not so many of those. All right. So, I guess as we look towards the cloud, for those couple of people who said you were looking towards moving to the cloud, why are you guys moving to the cloud? Why are your companies moving to the cloud?
Long-term strategic vision.
Say, what's that?
Long-term strategic vision.
Long-term strategic vision. Okay. What about your long-term strategic vision? Like, why though? Like, what is the business is making a decision? What was that about? To move to the cloud for a reason.
Yeah, the goal is to lower costs.
Lower costs, okay. I guess I did. I don't know why. So it's booting back up. So, anybody else? Lower cost, who else is, why are your companies making decisions to move to the cloud? I think no. Did you say you? Not you? You were doing Azure. Why are you guys looking at moving to Azure?
A lot of the SaaS, where I was basically, for cost, spitting it up, speed of getting stuff up.
Speed of getting stuff up, okay.
And basically, we're not getting more staff. So, with our strategy, if the SaaS will do it, but if I still got to patch it back up or whatever, it's not fit. But it helps out with staff reduction.
Okay, staff reduction, speed of deployment. Yep, those are very good reasons. Anyone else?
I'd throw in their expertise. Along with staff, it's not only do you have a lot of people, but this technology keeps changing. It's hard to keep
Yeah.
the right people on the staff.
Okay, good point. And this is, so, as I bring this back up. So those are all good reasons that I hear. A lot of other reasons that I tend to hear are things like availability. Because we want to increase our availability, or from a cost standpoint, going SaaS applications, a lot of people are like, that's usually where the people comes in, is it's easier to have like Office 365 and you just move it out there. So now you no longer have to take care of the Exchange. You no longer have to have the people who have expertise in Exchange. But as we look at some of the other reasons, flexibility, so I think that's what you mentioned there. Speed of deployment was mentioned. Automation is usually a reason that we see a lot of times. Scale, I like that as much rope as you're willing to pay for was the comment. So when you talk about scalability, because you're using the cloud, the model, you have to understand the cloud model is to get you to use the cloud because you're paying for everything that you use. That can be great if you've got DR sites up there and that's all you're doing. It can be great if you have to have environments that are very, very scalable. So you have to have environments that go up and down. Retailers right now is a great example. That this will be the holiday season. They're probably going to see more business concurrently right now than they will any other time of the year. So if they can just spend for those servers, those resources they're using right now, and not have to pay for that capacity that's going to be sitting there idle 75% of the rest of the year, then that is a cost savings. So today, from a security standpoint, I'm going to focus on AWS, which is infrastructure as a service. So basically, you're deploying applications out into the cloud on the servers that you're putting out there. There's also platform as a service and software as a service. We can, if you've got questions on those, please bring them up. I want this to be very, you guys have a lot of questions. I want it to be very back and forth as we're going through this. So, as I look at kind of some of the reasons for building a cloud, what the types of things that you can do as you move to the cloud, you have to think of it and change kind of the model or the mindset that you've gone into it. So traditionally, when we build out networks, we build out a network and say, okay, here's a block of addresses, I put my servers on those addresses, and I'm just going to continue to build stuff out like that. And a lot of people will say, okay, if I'm moving to the cloud, I'm going to take that concept that I had before, and I'm just going to carte blanche move it to the cloud. So I'm going to have my set of servers, I'm going to have my address blocks, I'm going to create a VPN connection back and forth, and it's just going to be basically another VLAN that I'm going to have, except for it's going to be stored up in the cloud. We really want to take advantages of the stuff that the cloud brings us and be able to deploy applications in the way that make it more beneficial. So if you take an example of this, you see here, I've got, this is the top one, would represent kind of like an Azure instance, and the bottom one would represent an AWS instance. Those are the same applications running on the same IP addresses, and you can actually use that just like it is. So if you've got an application that you want to be redundant across both of those providers, there's nothing that the app developers have to do. So when you're talking about speed of deployment and upgrades, there's nothing app developers have to do that is different between those. To them, a server is a server. It's got the same IP address. If I need a clone or DR, nothing changes. I just deploy it into that environment. So being able to take advantage of stuff like that and do load balancing is one of the key things. Is look at it as building blocks. So if I take a look at kind of what the process is, you'll see here I've got up top, this is, we're talking about AWS, so I've got a VPC. We'll get into all these terms later, so I'm going to try and define terms as we go. But we've got something in US West, so that's a region. We've got another one here in US East, and you saw I spun up another one here in US East. So I initially had Route 53. Does anyone know what that is? DNS, yes. So you can do load balancing of addresses. So I've got my two servers that are going to the services here. Those are load balanced across those. So I've got multiple regions, availability across multiple regions. And what I did was I just duplicated this entire VPC, cloned it down, and now I've got a fresh instance. I can do my upgrades, I can do my installs, I can do my testing, I can do my QA on the exact same instance that I have that I just cloned for my production. So I go to the next step, and I just roll that production instance into, or that test instance that's upgraded into my production. I'm now load balancing across those three instances. Everything goes well, then I can start taking out the other instances. So I'm now seamlessly upgrading my application systems. So when you think about kind of the scalability of what cloud is for, it's this type of stuff that you want to be able to think about, that you want to be able to use the advantages of. That make sense? So talking about where we look at security from the perspective, security, when you talk about cloud security, is very much a shared security model. So AWS, Microsoft and Azure, Google in their cloud, they're responsible for the service itself, for underneath the line. They're responsible for making sure that their stuff stays secure. They're not responsible for your servers, your infrastructure on top of it. You're responsible for that. You talk to Microsoft, and Microsoft is going to say, yes, we're secure. Or AWS is going to say, yes, we're secure. We meet all the compliance. We meet HIPAA compliance. We meet PCI compliance. All of that we meet. You're good to go. You'll have no issues if you deploy in our environment. That is absolutely true. It also absolutely leaves you very much exposed as long as if you don't put the protections in place. And that was, I mean, this is part of the reason why when we were talking about teaching, like going out and sharing with the community, that's part of the reason I wanted to do this, is because I've been in a couple of different customers now where they've had, in their case, it was Microsoft come in and say, hey, go ahead and deploy this out, roll this out, you're going to be safe, you're going to be good to go. And then they really, Microsoft wants to get you to use their stuff, so they're rolling that out. And didn't kind of properly do the security behind it, which causes problems. If you're going to do this, and there are reasons to do it, the business is saying there's reasons to do it, let's do it right the first time. So that's kind of what the goal is here. So security in the cloud is just like security on-prem. You've got security that you're putting on-prem, you've got firewalls, you've got WAFs, you've got load balancers, you've got all this stuff that you're putting on-prem to protect it. You're now moving all this stuff to the cloud. You still need the same security. All the reasons that you had when you put it on-prem, you still have all of those reasons in the cloud, all those things, those same things that you have to do. And a lot of times we don't think about that. So how do you actually go about it? It's really about data flows. Like when you look at what do I need to secure as I'm putting stuff up there, look at the data flows. What is the data that's important? What are the things that you need to look at? Is there toxic information you're putting up there, meaning it's PII, PCI, intellectual property, or PHI? If that data is going up there, you absolutely have to have extra controls. And by the way, there's a lot of people that are moving that data up there. Specifically, there's a lot of people that are moving PCI data up into the cloud because they can say, okay, I've got a VPC. A VPC is a private network. I segment everything up there. If that's my PCI scope, then I only have to scan one PCI scope. And I can secure everything inside that PCI scope. I send all my APIs, calls up to that to do my processing. And then I don't have to have all those scans and all those audits on my regular network. So I mitigate a lot of that. You're laughing. It's true, though.
I believe it. It's kind of funny.
So as we get to the framework and kind of going through the definitions, we look at EC2. So we're talking about AWS. EC2 is your elastic compute. That is the stuff that you're basically using to build servers. So your instances, your network interfaces, load balancers, scaling groups, that's the stuff that's in EC2. It's where you go to add the compute cycles, which is your power, your CPU. S3 is your storage. A lot of times you will do storage and you'll add storage accounts and bit buckets and stuff like that. That gets stored in S3. A region. These are all regions up here. So those are basically the regions that AWS has. Those are data centers. That's how you break it down. There are differences between what data centers support. So certain data centers only support certain instance sizes. So if you need to have a requirement that says this region is going to actually mirror something over to this region over here, and I'm going to do replication, and I'm going to have automatic failover and stuff like that, you need to make sure that you get regions that are the same, that are compatible, because they're basically like waves that when AWS built the data centers that have certain types of hardware and support certain things, those kind of waves are the ones that match. So you need to make sure you have regions that match those kind of waves. And IAM is, I've added it here, not because it's necessarily a security thing that we're building in, but that's what gives you access to your AWS account. You should really put two-factor authentication on that, because there's been lots of cases where people may be like programming and coding stuff in GitHub, and they end up putting their credentials in there for their AWS account. And GitHub is a lot of times open, and so people are going in and finding that hard-coded credentials to change stuff. And now somebody has your AWS account, and guess what you can spin up with an AWS account? You can spin up really expensive servers to do things like Bitcoin mining. Guess how fast that bill goes? It's really, really fast. So make sure you put like two-factor authentication in front of that. Yes?
So this is probably my developer showing, but how come you didn't mention Lambda?
So because there's a whole slew of other things.
Okay.
So yeah, so there's Lambda functions, which are basically, you can put code in there that can run, and it can do other stuff to AWS itself. So it's really interesting. Like, I don't know a ton about it because I'm not a programmer, but it's really interesting. If you want to talk about it, you give a description. What's Lambda?
I mean, basically, so your elastic compute is, I want to run very scoped and it's very scaled down as opposed to I want to compute, anything. I want to be Wolfram Alpha. No, Lambda's like, okay, I'm a calculator. That's what I do. That's grossly oversimplifying, but it's just interesting to me because a lot of times people will, in a security context, because a lot of times people will take that for granted and act like since it is so ephemeral, it must be secure. So it doesn't matter what data I put up here to run my compute over, it's going to go away. And that is 100% not the case. It goes away to you, but that doesn't mean you can just turn a blind eye to security.
Yeah. Well, and that's the same thing with, is it Cosmo? There's new DBs they've released because they have the same thing from a database perspective now, that you can just run, this is my one little database up there and I'm just doing it. And so we use, there's some extra functionality that we use where we're saying, okay, I'm going to take x44 addresses and I'm going to run them through Lambda code, or if I'm auto-scaling stuff out and we see a certain percentage of traffic, then we need to add more instances and we auto-scale those. And we try and do automation for all that. So we automatically add the addresses and the tags and all of that stuff to make it all work. All that is, for us, is done in Lambda code because we're saying, okay, we're watching CloudWatch, which is another piece where you're basically monitoring the status of your systems. And based on that, we're taking some action. That action gets called into Lambda code. Lambda code runs this process and tells this thing to do some other stuff. So, yeah, those are all pieces. Thank you for bringing that up. If there's more stuff that I missed along the way from anybody, please do. So VPC. A VPC is a virtual private network. That's basically it. It's your big virtual private network. That's layer 2. Most of the time, you're going to see it's a /16. You can go all the way down to a /28. Usually, they say design this to be bigger because then you can grow if you need to. If you make it smaller, then you have to wipe it out and you're going to rebuild everything up in a bigger one. And it's lots of space. So they just say reuse it, make it as big as you want, up to a /16. You can make lots of them. There are reasons to make lots of them that we'll get into when we get to the routing, depending on what your architecture looks like. Trying to think what else about VPCs. So that example that I showed where I had several that were the same IP addresses, that's most of the time that is not the best practice per se, depending on what your architecture is. If your architecture was that exact thing where I've got an app and I've got this multiple app that I'm doing over and over and over again, then you can do something like that because you're just going to go hit the public front-end IP address. If you ever want these VPCs to be able to talk to one another, so if you've got web server and it has to talk to a database server and it's got to talk to another database server, and those are all going to be in AWS and you want to do segmentation between them and have them talk to each other, the backend IP addresses have to be different. So they have to be in different connections. Does that make sense?
They won't sell you NAT?
What's that?
They won't sell you a NAT service between the two?
So you can do that, but there's a cost thing when you get to that.
I just want to know if that was.
Yeah, you can.
Most
of the time, you're going to want to, best practice, if you're going to be able to do that, is to just create separate ones, because you can create VPC peers, and the cost of having a direct VPC peer between two VPCs is less than having another NAT instance and funneling that additional traffic through that NAT instance to go back. So best practice is create them with separate ones in those cases. Subnets then. So your subnets are how you break up your VPCs. So you see each one of these subnets, you basically have two kinds of subnets. You have public subnets and you have private subnets. Public subnets have an internet gateway associated with them. So all of these have a main route table. That route table, and you can see the route tables are up here. So you see every single subnet has this local address, or this local one, that's for the entire VPC. So inside this subnet has a way to talk to everything else in the VPC. The other thing that you can do is you can add custom ones. So because it's public, it's got this internet gateway address, so 0.0.0 goes to the internet gateway. So that's been added. So that makes this particular one a public one. This one down here is a private one. So in order for it to get to the internet, it's got a route that says, in order to go to 0.0.0, I have to go to this NAT gateway that's in my public address in order to be able to get out. So you can build subnets like that. You see I've got a whole bunch of different, I took a screenshot down here, so I've got a whole bunch of different subnets, and each one of those subnets I have private. So I want to split up my applications behind there into different availability zones. So as I'm doing that, I've got multiple different subnets, and each one of those availability zones control what it's doing as an example, but the important thing is public and private. Those are your two main options, and you can have individual route tables for each one that we'll get into more. Instances, there's a lot of different instances. This is basically the size of compute that you want. So different compute can run different stuff. A lot of times, even the security appliances that you're going to get will run on instances. So like we have VMs. Our VMs will run on an instance. Your throughput is based on the size of VM that you get and the size of instance. The bigger you are, the more you can do, more cost. Smaller you are, less throughput, cost. Make sense? Load balancers. So when you're architecting an AWS instance or an AWS design, load balancers is what has started to become really, really important. So you can do things like have traditional HA where you've got an IP address and it's maybe a floating IP address, and so you send traffic to that, and you can do failover. It's really not recommended because you have to, everything that's happening in AWS is based on an API. So if there's some action that happens and you need to do a failover for some reason, doing an HA failover like you traditionally do on the network side can take 30 seconds, 5 minutes. It can take a long time, which is not what you want from an availability perspective. So what they do, and the concept is called load balancers. And there's a couple of different load balancers that AWS has. There is the application load balancer. This one is fairly new. The network load balancer, the classic load balancer. That is traditionally what they have. You see these two are supported only in VPCs. This is like an EC2 Classic. Hopefully no one out there still has EC2 Classic. Try and move off of it if you do. This is basically the newer version of this. They haven't said it, but I would say this is going away. There's little buttons everywhere that say, do you want to upgrade if you've got a classic load balancer? So, and I've got another screenshot that shows like the features that are supported. As you're going through, there's a couple important things to think about when you're doing load balancing. The main one is you see that preserve source IP from a feature. This application load balancer, can only look at HTTP and HTTPS traffic. But as a part of that, it's doing a destination NAT for any traffic that's coming in. So the way traffic kind of works is you'll say, here I've got an IP address or a DNS address. That's going to go to the load balancer. The load balancer has targets behind it. Those are basically instances or other CPUs. It needs to check and make sure those are alive. That determines where it's going to be able to send traffic. So with the application load balancer, it's able to do decryption on it. So if you've got like a PCI zone that I mentioned before, where you've got these servers behind it and you need to be able to do IPS in it, you're going to have an application load balancer. You're going to be decrypting that traffic from the PCI on that load balancer so it's unencrypted behind it. Then you can put your IPS that you need to meet compliance requirements behind that load balancer. But you lose all visibility to what that outside traffic is. So you just, like, on whatever that appliance is or whatever that instance is, all you see is the traffic coming in is from my load balancer IP address. You don't see what the other one is. It is contained in the Next4 header, so there are ways to grab it, but it's not like an IP address. So if you've got a case where you want to say, I want to do geo-blocking to my ADFS environment that's front-ending my Office 365 instance using an application load balancer, makes that a lot more difficult because you don't know what the IP address is without breaking it out. So they have another one here that's called a network load balancer. That is basically just an IP load balancer that's going to copy that traffic through, and its health checks are all based on TCP protocols, not HTTP protocols. So there's limitations in that it can't do decryption. It can't basically break open the traffic. If you've got like, another example for the application is, let's say that you've got a website and you've got this website going to various different instance groups. So maybe I've got like an orders group and I've got a shopping cart, or I've got like the store. And I've got these in different websites that have different groups behind them. And I want to be able to have one load balancer to separate those out. The application load balancer can do that. The network load balancer can't do that because it doesn't know what that underlying address is. Does that make sense? And so this one, if you're using this one, you can see all that information. So you can apply a threat list to it. You can say, hey, I know that this is a threat coming in. I want to be able to block this threat, or I want to block this geo. I want to do things like that. That's really, really small. I apologize. Thought it was going to be bigger. There. So here's the list of all the other stuff. As you look here, this is the application load balancer versus the classic. And so you see some of the other important features. We've got back-end encryption, SSL offloading, what's native HTTP support, host-based routing. So there's a bunch of other important ones on there that you can do that are not supported over here. And then these couple are the important ones for this. Down at the bottom where you've got source IP, that's really what changes a lot of that. So here is the example I was talking about. So if you've got a load balancer up here, and you put your groups down here, and you're looking at it, the application load balancer can split those out, where a network load balancer couldn't. From a traffic flow perspective, this is what it would look like from a network load balancer. Is I come in here, and I've got an IP address. That IP address can actually then look and send traffic to either one of these, whichever one is up, and then that'll send traffic to the network load balancer, and that'll send it, if it was headed to one of these, that'll send it to there, or that will send the traffic to that load balancer to go to that application. So from a network flow, that's kind of how you secure it from a network load balancer perspective, and so you can have all your policies that you would normally have in a firewall on these right here. So you're managing them just like you would on premise. So the routing, this is kind of, when you're thinking about architectures and securing it, this is where that comes in. And this is where Azure is the most different. So in AWS, I said each one of these has its own routing table applied. In Azure, you've got a completely different thing. So subnets can have their own routing tables, but you build UDRs, and so you can actually overwrite that default layer 2 route. So you have a lot more flexibility in being able to kind of do east-west segmentation and outbound control, where you can't really do that with the way AWS is set up.
So those are domains, the EU West 1 and EU West 1B, those represent domains?
Yeah, so that is a region. EU West 1A is an availability zone. So availability zones are going to be inside of data centers. You basically have different hardware and different power. So if there's a hardware or power failure inside one of their single EU West data center in this case, it could affect only one availability zone. It wouldn't affect the other availability zones. So that's what the 1A, 1B, and 1C means. And on Azure side from availability zones, that is only in public beta today. They only have availability sets, which are basically, they've got some different servers that they upgrade at different times today. They don't have full availability zones where they've got different power and different servers inside of your segmentation. So that's another difference between AWS and Azure. So as you look at, there's a couple here, you can see you can have secondary IP addresses on it. So for some reason, like you were saying, is there something else I can do? You can attach secondary IP addresses to it. But your best bet is try to not overlap. Where you can, especially if you're ever going to have them talk to each other. If you're never going to have them talk to each other, which was that very first case I put up, then go ahead, because that's the architecture that you're trying to build for. So by default, all of these have a routing table that says send everything to the local router. So there's a local router kind of hidden inside of everywhere in AWS. By default, send everything to that local router. You cannot delete it. You cannot overwrite it. You cannot like supersede it. So I can't say like I want to put a route in here for 172.16.0.0/24. It's not going to work. It doesn't. It's not like whatever is the most defined is not going to be what gets processed first. It doesn't work like that in AWS. So all traffic is going to go to there. If we change this up and we change where the local router is, and we now build various different routes. So you see we've added an internet gateway. So these are now public subnets. The traffic for these is going to the router and going to the internet gateway, because there's the router. The router has internet gateway to 0.0.0.0. So traffic for both of these goes out to the internet gateway. We also have up here this VPC NAT gateway. That can be, I mean, they have a NAT gateway that you can provide, or it can be an instance. Because one thing that you have to keep in mind as you're looking at the security of this thing as a whole is, from a logging perspective, what logs are you getting in AWS? What logs are you getting in Azure? That's usually one of the biggest things when people move to the cloud and don't think about that part of it. They lose a ton of visibility. Because now all of a sudden you can do flow logs, but you're going to be sending flow logs in JSON format to sit on your S3 bucket, and then you have to write something else to pick up those, and then you have to send those to the SIM, and really people don't want to do that because they're used to just send it to my syslog. My syslog goes to my SIM, and I can process it on my SIM, or I can process it however I'm going to process. Most people don't have the developers like you would to be able to say, I'm going to pull my JSONs off my S3 bucket. So VPC NAT is an instance. Again, it's from them, so their goal is not logging. Their goal is functionality. How can I get you to consume this? So there's not a ton of logging that happens there. You can have that NAT be a separate virtual appliance. So whether it's ours or somebody else's, it can be a separate virtual appliance. And that will provide you the logging that you're used to getting from whatever your solution is. The routing that we added here was this, we added to the NAT gateway. So now the traffic for there, 0.0.0 goes to the NAT gateway. And so that could head to maybe another VPC, or it could head somewhere else. Wherever you have the route in this NAT gateway pointing to, that's where the traffic is going to go. So wherever its next hop is for that traffic. Elastic IPs. So this is the difference between AWS and AWS and Azure. Is by default you see everything gets virtual private IPs. These are usually assigned by DHCP, and then you can set them to be static, or you can do like DHCP reservation type of things. Assign what those addresses are. You can also, you want public IPs for most cases. So by default, AWS, you can only have 5 per VPC for your public IPs. Again, you pay for all of this stuff. That gives you the ability to log in. You'll notice on here, I've actually got 3 public IPs, which are called elastic IPs. 2 are for my firewall management, right here, and 1 is for my external load balancer. So that means I can log into my firewalls to see what I'm doing, and I can see my visibility because that's what I do. The other one is for the load balancer. It's a public address and load balancer. Everything then has to come through that load balancer. So if I needed to be able to get it to whatever those backend servers, I would essentially have to have like a jump server in a separate subnet to be able to log in or do translations to some other backend servers. So stuff like that is pretty common. It's usually called bastions, or what they're called in AWS terms. Questions on that? That also led us to security groups. So you saw, because I had a public IP for my firewall management, that's a really bad thing. Who puts their management interfaces on the public internet? Because do you know what happens when you put a management interface on the public internet that has SSH and HTTPS set? You instantly, yes, people are instantly beating on it. Instantly beating on it. So, best practice, so that they have, AWS has things called security groups. Those are layer 4 stateful firewalls, essentially. So you can put in your layer 4 type of rules that you've got. You don't have any logging for when stuff is going across those, but you can say, hey, I want to use a security group, and this is like my home IP that I'm allowed to SSH and I'm allowed to HTTPS just from my home IP address. And one of the options in the dropdown is usually choose my IP, so it'll help you, it'll like automatically pull what IP you're connecting into EC2 from. So you do want to use those because that can save you from getting your box compromised before you can log into it yourself, because there's more people out there that are just randomly beating on it than you can move, or faster than you can move from an automated system perspective. And you see it's just, the way they work is just port, protocol, source address. And this is outbound by default, or this is inbound rules. You can't set up outbound rules. By default, there are no outbound rules. Everything is allowed outbound. Oh, I was going to say that. So the difference between Azure by default, automatically everything gets public IPs unless you remove it, and automatically all traffic is outbound. Like everything is only outbound. That is a very big difference, because now all of your servers, anything that you build up, automatically has a public IP address. Most of the time, when they build, when people build their security, there's like, they're called network security groups inside of Azure. They will say, hey, I need to get to this, and so they're going to assign a network security group to that gives them access. Most of the time, it's going to be a system admin. Most of the time, that system admin doesn't realize what they're doing from a security perspective. They just want it to work. And so they'll do things like say, because they'll follow the Microsoft documentation that says, allow port 3389 inbound into my instance. So you've now just opened up your server to RDP.
It's even worse than that.
Okay.
So if you go into AWS and say, I want to create a new server, and you know about network security groups, you think this is a good idea, it will let you create one for you at the time you build a server, which is cool. And it'll automatically punch a hole in it for RDP. But they don't make a big deal about it. You have to really, really pay attention. So a lot of people go in, they think they're setting up their NSG, they've got all their other connectivity to VPN, they think they're good, and they're still out there.
Yeah. They make it easy to use. You have to remember what the goal of Microsoft and AWS is. Easy to use, and they're usually targeted to developers or targeted to your system admins, because that's how they're going to, and they're getting people to move over. So if you are at an even medium-sized organization where there are system admins and developers, they're probably already using Azure or AWS. Like if you've got like a Microsoft Enterprise Agreement, it's almost guaranteed they're already using Azure, because Microsoft is giving you Azure in your Microsoft Enterprise Agreement. So people are using it, and they don't come to you to ask permission to use it, they just set it up. There are also ACLs. Those are stateless ones. I have no idea why you would use an ACL. I don't have a good reason for it. So here's all, when we were talking about gateways, here's all of the different other ways that you can basically have traffic exit out. So your internet gateways, NAT gateways, says private subnets reach internet outbound only. Customer gateways would be basically, you've got your device on premise, so think of it as like you've got a firewall, you've got a router, an ASR, whatever it is, you've got a tunnel, that's your on-premise gateway. That's their logo for what you have on-prem. VP, or virtual private gateway, or VPG, is the other side of that you put in AWS. So they have gateways that can specifically build IPsec tunnels to your on-premise networks to have that connection. And so those can be gateways. Direct Connect is how you need to reduce latency, so you can basically think of it as like buying an MPLS circuit directly to them for reduced latency. Peering is I can have connections between the two, and VPC endpoint is I need to have like a direct connection to S3 somewhere else, or I need to have a direct connection. I can create an endpoint to that other database or S3 connection or whatever that is. So all of those things can be other stuff that you can use in that routing table when you're customizing that routing table. Make sense? Are there any questions? I want questions. Somebody's got to have a question.
So can you talk a little bit more about endpoints? So I know with Azure, one of the big limitations is the ability to kind of restrict around any time you're consuming as service. Is down that path of not so blah?
Yeah, so for Azure specifically, there are some of the PaaS appliances that you can change the mode from a proxy mode to a transport mode or transparent mode. It's proxy to, I think it's transport. I don't remember exactly what the terminology they use. So proxy mode means you're just directly going to the internet proxy. If you switch it, like SQL I know is the one that you can switch it to do transport, and you can basically send that traffic over to, it's not called a VPC, it's another type of endpoint, but there is an endpoint in Azure that you can send that traffic over, so you can do that inspection on that traffic. But I know it's only for SQL, I don't know about their other services. Okay, there's a lot of conversation around PaaS and getting control of PaaS right now. We're struggling with it mainly because Microsoft doesn't support it. So go ask your Microsoft rep why they don't support it. That's what the answer to that is, unfortunately. Scaling groups. So as we talk about scaling groups, part of the reason for the cloud is how do I go up in size? How do I go down in size? How do I meet the needs so I'm only spending the amount of money that I need to spend? Which is why we've got growage and shrinkage. And this dates me because I don't know how long it's been on since Seinfeld's been on, but when you say shrinkage, that's still what you think about. So essentially what we're doing is saying, okay, there's this much of these resources being utilized on these instances. And because of that, do I need to grow the instances and make them larger? Or at what point do I need to reduce the amount of instances? And what's the minimum number of instances? What's the maximum number of instances? That's what scaling groups are. So they try and do that all automatically, so that way you have the flexibility that you need inside of AWS. This Azure is not near as far along in AWS from scaling groups. So that is, they're both trying to catch up. Well, Azure is trying to catch up very much, but I think this is one area where they're a little further ahead. Questions on scaling groups? So, putting it all together, and what's it look like to finally build kind of a secure architecture? How do I get in the cloud what I am used to having on-prem? And so here's one example where I got another very small picture, but there's a lot going on, so I didn't want to make it bigger. I've got a multi-tier application, so I've got web servers up here. I've got a couple of different web servers going across it. I've got different load balancers that are doing different stuff. So like the red is an ALB, I believe, and so it's doing decryption on traffic as it's going back through. It's got an NLB back here because it doesn't need to do anything else, so it's just going to pass it through as it gets back there. I've got an NLB over here, so it's already encrypted, and that traffic is just getting passed to the sets right there. And then these web servers then need to talk to these back-end instances. So they need to talk to, I can't even read that. I can't read it on that screen either. So they need to talk to the DB layers, the app layers, maybe it's SharePoint, and it's got to go from the SharePoint front-end server back here to this server, and then it's got to go up here, back to your database back here. So you've got those type of things going on. This is kind of the architecture that you would use. So I've got load balancers up here, go to load balancers. This talks to that VPN gateway. That VPN gateway goes to load balancers inside of here. Actually, I've got BGP routing going on between these, so they are all redundant. That goes to this, which goes to the load balancers down here, which talks to this, which goes back to the NAT gateway. NAT gateway is rerouted to these, which can be routed back to here. So there's a lot of architecture that you can do from a traffic flow perspective. And I wanted to try and dig into some more, like this is a very busy one, dig into some simpler ones to start off with it, if that makes sense. Are there questions that you want me to address as we go through here from an architecture, since I think the majority of you were closer to like a network engineer type of side? No? Okay. So the easiest one is a single tier. So I've got an external load balancer. This can be the it's built in, or you can also, when we talk about security, you can also use stuff like F5s that have WAFs built in, WAFs. So WAFs is another security appliance that you can kind of put in this processor flow. Microsoft and AWS both have their own. Microsoft is mostly focused on OWASP top 10 type of stuff, where AWS is focused on signatures. AWS, you can actually, if you had multiple, think of AWS is going to be closer to being able to have the same WAF installed on multiple different like load balancers, so you can have multiple applications that you're covering, where in Microsoft, it is one per one. If you've got an application, this one application is covered by this one WAF. So you have to deploy it one for one every single time. Web farm, you can scale out the web farm as needed, so you can put this in a scaling group, and the more websites you need. So if you decide to do some crazy, great blog, and you've got like WordPress instances that are going like crazy, WordPress, I mean, how much of the internet is WordPress blogs? It's a lot. Or runs on WordPress. That's why you guys are always going to have a job. So we take a look at an example of, let's say this is a DMZ. So I want to look at outbound traffic in these cases. So I've got a set of instances where I'm inspecting traffic that's going out or inbound in both of these, since it's headed to this VPC here. So traffic can either come in and it goes down to the various different instances, prod, non-prod, sandbox is the other one we've got up there. And then from an outbound traffic flow, because it's got peering, no, this one is inbound only. I think I did an outbound one separately. Sorry, this one is inbound only. So you're able to do essentially DMZs between those, but if for some reason this would make sense, then mine, prod wouldn't be talking on prod, doesn't make sense, ignore that. So this is this type of design. Questions on that? An inbound, so here's building out what an inbound architecture looks like. It would be scaling out, having health check. Oh, so did I say health checks before? Did I already cover that? No. So each one of these load balancers has a thing called health checks. So this load balancer is checking both of these instances. This load balancer is checking these instances. This load balancer is checking these instances. And it's doing a health check in order to do that, to determine which one of those is up. So if one goes down, it's not going to send traffic to that one. So you've got TCP, IP. This was talking about network load balancers, so those are TCP ones only. Otherwise, I think we talked about most of the rest of that, and I don't want to make you guys sit here forever. You're building out various different security zones as you've got traffic here. So essentially, when you have firewalls on-premise today, usually you end up having some sort of, I've got an external side or my internet-facing side, and I've got an internal side. It's going to work a similar way up in the cloud, where you usually have, for lack of better terms, we call it a trust zone and an untrust zone most of the time. And that trust zone is really just going to be your private IPs. I hate to say trust zones because nothing should ever be trusted, but but that is what's often called. So you end up building those here, and then traffic would be able to flow through. I think, is this the one where I've got walkthrough? Yes. So this is the walkthrough where we've got the same thing, but we break it down. So you see, you've got two availability zones. So these are different availability zones inside a single instance or a single VPC. And these network load balancers, they're splitting across it. Technically, they're not splitting, but for the sake of simplicity, you can make them split and share. So that would probably be a question if you would catch me on that. This diagram is technically incorrect, but for the sake of functionality, that's what traffic looks like. Is you start at the external one and have traffic move to the internal one. This is why they're technically separate, because you have this load balancer, and this load balancer is really only covering these. This one's covering this one, this one's covering this one, and this one's covering that instance. You can do other stuff, like make them cross-compatible, so I can actually split. The traffic flow gets more complicated, but you have better decision distribution when you do stuff like that. From a multiple applications. So in these cases, it's going to work the same way. Traffic coming in, going across these, and then it's splitting into the multiple applications. So it's just not having as deep, having more broad of a design. This is for outbound. This is the one that I was misthinking. So here we've got outbound connections where instead of traffic has already made it in using that other design, but we're using the same DMZ design here. And from an outbound perspective, you've got stuff in the prod account that actually needs to go to some database that's sitting back at corporate, or sitting back at headquarters, or sitting back at your colo. You end up having the gateway here. Gateway here has the next direction to your on-premise device, and you're doing filtering for that on-premise device before it comes in. I would highly recommend that if you don't do a connection somewhere in here, like if you don't do a virtual kind of segmentation, virtual firewalls, virtual whatever it is, you have them terminating into physical ones. Don't just terminate that tunnel into like an ASR that goes directly into your core network that has access to everything. Because these are all in the cloud, and especially with like AWS or no, Azure that we were talking about, it's got public addresses, or people in AWS where you've got a developer up here that all of a sudden decides to do that 3389 rule from anywhere. And then this machine gets popped, and it has direct access, unfiltered, no visibility, directly back into your data center. That makes those people from Trusted Secure very happy. Automation. So, was there any questions on that? So, from an automation side, I want to talk about this because, like I had mentioned, or like I had the question or made a comment on before, this is what's becoming more important: is how do we make this scalable? Because now you're talking about things that are automatically scaling up and automatically scaling down, and I can't do change control rules. How do I keep the business moving fast enough? Because if somebody puts a change control issue in a week before and it can't be executed until next week, the server team's going to kill me because that doesn't meet the needs and the requirements of this. So how do I keep this moving? So there's a lot of things that I can talk about how we do it. I don't know how everyone else does it, so I've been trying to stay as unspecific to us as possible, but this is one of the places where I don't know what else they have, so I'm going to talk about how we do it, is being able to pull the metadata. So you've got tags in AWS and Azure that are assigned to each one of these kind of instances. So this is a web app, and I know that this web app is now, we're going to call it App Web 1, or App 1 Web, I guess, is what's up there. So I know what that's doing. I can build security policies around App Web 1. As I scale it out, that security policy is going to stay the same. Like the IP addresses are technically going to change because I'm adding new servers and deleting servers. So I need to be able to change and remove those so that I keep everything up to date. But I need to be able to do it in an automated way and not have a manual change control process. So the way we end up doing it is we can actually pull that metadata and bring that metadata in so we can essentially say, okay, we know what these IP addresses are. These IP addresses are associated with this application because this application is what's marked with the tags. So maybe this is the app, or this is the DB, or it could be this is a Windows server, or this is a Linux server. Maybe I have to open up RDP versus SSH for the developer to be able to get in from wherever they're coming in from, just not straight to the internet. So you're putting that in, you're using stuff like Lambda in some cases to be able to do this. Some of this can be done on the firewall itself. We have a central management platform because now you've got multiple different firewalls. So in order to be able to push it out to multiple different ones, we need an automated way to change all of those firewalls at once because you've got lots of different things you're bringing up and down. And so ours is called this. That's what Panorama is in this case. It's our way of being able to do that. So we've got all of these different tags. So IP address A is App1 Web. These are basically all App1 Webs. They could be DBs or DBs. Probably, in fact, that should say DB or DB and not all App1 Web. That could be a slide modification, but So the policy in this case is app1web is allowed to talk to the app server. So the central platform is going to update all of the other firewalls to be able to do that. And it's going to automatically create change logs to show that that's what happened. So you've got audit trails. There's other things where I've got now have it building out and creating additional rules. So maybe I have to have additional policies going to app1bb. So I've got other servers, I've got other stuff, I've got my RDP sessions that I have to have going on, whatever the case may be. You use these building blocks, and you can get more complicated with your building blocks, which is why, again, I talked about the people who can design the stuff that makes all this happen automatically is where your future kind of job is, not just the guy who, hey, I can go in, I can look up this server, and I'm going to add this server's IP address to this list. That's a manual way of doing things. When I can write the stuff that says, I'm going to automatically pull all of these servers and add all of these servers' IPs list, and then I'm going to automatically take them out when those servers get deleted. That's the automated way of doing things that we have to get to. So you scale it out, you've got multiple different ones, you've got policy that's the same across all of them. You've got policy there right into your SIM, again, because you've got reports going from each one of these things back to a central place. So you can report it all from that central place to your SIM, have visibility, or you can, if you really wanted to, you can just dump all of that stuff into the SIM and create a bunch of different rules for your SIM. And this was another interesting, from a standpoint of how does it cost? The VP, that was the reason. So the VPC tiering, when I was talking about doing the multi-tier one where I had the web servers, and then it was going to a different layer of stuff, and then that was going to a different layer of stuff. Any traffic that goes between those tiers costs you money. Traffic that stays inside those tiers normally does not cost you money. So that's another thing to keep in mind as you're architecting and you're designing out. What do I actually need from my application? Is security required between tiers, yes or no? Is redundancy required between tiers? Do I need to have multiple load balancers between that I would have to structure the traffic to be able to route through that to provide that? Because that could cost extra from a data between there versus I've just got one big blob of stuff and it just talks, which is usually less good on the security side, but I know that isn't what always makes the decisions. So this was an interesting visual that shows all the different places that AWS is charging you money. If you want to try it yourself, we have a pretty extensive GitHub list to be able to it'll automatically roll out a couple of these different options, and you can see what it looks like. Or if you've got your own instances that you want to test up, us as well as a lot of people have stuff on the marketplace. So you can just go to the marketplace and you either do a pay-as-you-go, or if you contact us for the shameless plug, we can get you a free license to test with, but that's it.